Here's a 100-watt solar panel. Cables are sold separately. 100 watts. So it's a mono-crystalline panel. And it doesn't look as the image of the seller. The box is empty. So it has 1, 2, 3, 4 by 1, 2, 3, 4, 5, 6, 7, 8, 9, 4 by 9, 36 cells. It has aluminium frame. So it's aluminium. We have some holes, mounting holes, not too many. That's the label. EcoDeltaPower.com. Photovoltaic module. Open circuit voltage 22 volts. Max power voltage, so that's under load, it's 18.1 volts. Max fuse 15 amp. Max current 5.52 amps. Electrical hazard. 2 connectors. Positive and negative. Theoretically it has a diode inside. At this much light it gives 0.2 volts, which is not much. Zero amps. So this is the plus, which has a red ring on it, which comes from here. Plus is visible here. So let's attach a cable. It says do not disconnect under load. It has these 2 clips. You have to push in those to remove it. It made a click and that's it. That's the negative, that also has a red ring there, but it's black. Now the power is here. Luckily I'm inside and there's not much power in it. And short circuit solar panels, no damage will occur. So here's the wire which comes from the solar panel. Of course outside probably you will see some sparks because it will have much more power, but here we have half a volt and 0 amps, so there is no spark. So here's this solar panel, 100 watts, and we have no clouds. It's August 17, so the sunshine is pretty powerful, and it's kinda at 90 degrees to the sun, and it's giving me 20.4 volts DC. The maximum, it says it's 22 volts, which is open circuit voltage VOC. Let's see how that voltage varies if I tilt the solar panel. 20.0. It has no shadow somewhere here, so there is no direct sunshine, and it's giving me 18 volts. 18 volts when there is no shadow. On perpendicular it gives 20 volts DC, and 20.5 is the maximum, even if it's down. 20.2 when it's totally down. We have some shadow there, 20.2. Let's see without that shadow, 20.3. Let's block some modules. I'm blocking one, 20.2. I'm blocking 2, 20.2. It's not dropping. Let's block the third one, also 20.2. Fourth one, 20.1. So it's pretty good from this blocking point of view. A little bit more. 19, that blocks it even more. If I block it with my hand, there's still light from the sky, but this blocks it even more. 19.7. When it's totally blocked, it gives 0.3 volts. When it's facing away from the sunshine, it gives 70 volts. 16.9. 17 with 0 shadow. Now let's measure the amperage. To do that we have to move this to the 10 amp settings, and we have to move that one up there. Okay, and if I connect the red, now it will be short circuit. You can short circuit a solar panel. So let's see the amps. So 0.5 amps when it's in shadow, so the sun is hitting it from that side. Now with zero shadow it gives 0.7 amps. 0.7 laid down totally it gives 4.7 amps. And at an angle, let's say 90 degrees to the sun, 5.7 amps. That's pretty good. So since the amp measurement is a short circuit, the wires will heat up, especially these thin wires. Plus we have sparks. I'm not sure if you can see it. Yes, it's visible. It's even welding it. It's leaving spots there. So I just multiplied that 5.7 amps with 21 volts and it's giving me 120 watts from a 100 watt solar panel. That's pretty good. So I have a good old charge controller. It's just a PWM, pulse width modulation. This has lower efficiency compared to MPPT, maximum power point tracking ones. So let's connect these MC4 connectors. And there's a positive. Now we have a female to male and it's identical, so you can connect this end to that end. So it's the same connector attached to different ends. Now this plus and minus from the solar panel has to enter here to the first two. Plus is on the left and minus is on the right. That's the solar panel. Here we have the battery and there we have a consumer, a load. By the way, these wires are pretty thick. I also soldered them so they won't open, won't be damaged, and that much is entering here. Luckily it's entering because I had to move it, rotate it inside until the diameter got a little bit smaller so it somehow enters there, and I have to tighten those two screws. But before this, it's recommended to connect the battery first and then this. But let's just try it. So when this is connected, a white LED should come on there. So yes, there is a white LED because the solar panel is giving us power. Okay, let's connect the battery first. So here's an older car battery and it's not holding the charge quite well. We have these caps, remove them, and I have these from another battery charger, so I will hook those up there. And that's minus. Let's connect the multimeter, negative there and positive there. 12.5 volts. It was fully charged but it's not perfect. Now let's connect the solar panel also. I'm using just a 220 volt connector, a wire which is connected here, and I'm connecting the battery to the charge controller. The red LED should come on like so. Now let's connect the solar panel also, and I connect the solar panel. It's making a buzzing noise. The relay is opening and closing very fast. And this goes up to 13 volts. And then it stops. Now the sky is a bit less powerful and it's not buzzing. 12.7 when it's connected. 6 and dropping when it's not connecting, and it's not buzzing now. We have the white LED here, so we have power from the solar panel. 12.8. So the charge controller theoretically should limit the input voltage which comes from the solar panel into the battery. Let's leave it there, let's see what happens. So the battery is clearly visibly being charged. It's climbing. I can hear slightly bubbling noise coming from the battery, 13.7 volts. So we have a solar panel, we have a battery, we have a charge controller. That's just a multimeter, you can neglect that one. But we have also a load here, it's a 12 volt fridge. Let's connect that one. So this should have no direct sunlight, which currently does not have. 12 volt DC is connected here. And it has crocodile connectors. Let's connect those directly to the battery. Voltage is dropping. And the machine is working. We have a green light there. So power comes in at the solar panel, goes into the charge controller, and from there to the battery. From the battery goes to the fridge, and that voltage should not drop too much. So if I disconnect the fridge, the voltage should increase, not much, but it's steadily increasing. It's connected to the solar panel. Now let's see how much it will drop with the solar panel connected and no direct sunshine on the solar panel. 12.10, something like that. So although there is no direct sunlight, the solar panel is still able to maintain the voltage level of the battery with this fridge running. 12.08. 12.09, so it's not dropping, it's slightly going up, even with no direct sunlight. By the way, the fridge consumes around 50 watts. So the sun came out, we have light and we have shadow already, and from 12.08 it went up to 12.13. So it's speeding up. In no direct sunlight we are not in deficit, but the voltage is slightly going up. We have an object here which casts a shadow onto my solar panel. These wires which come from the fridge are thicker, they are not warming up. My wire is also thicker, I replaced it, that's not warming up. And these wires which go from a battery to the charge controller are thin, but they are not warming up. Of course there is no direct sunlight, so there is not too much amperage, but it's not warm at all. Now the fridge is connected directly onto the battery, but let's try to connect it here where the load is, that bulb. I have a long cable here, I think it's 20 meters, which is not too good for DC, because low voltage and long cables will generate higher power losses. That's why this 5-meter cable is that thick, and this is 20 meters and it's thinner. Now the load, the fridge is connected not directly to the battery, but to the charge controller through this long cable, crocodile connectors and the 12-volt plug. Battery is at 12.44. Let's power this on. 12.24. Oopsie. So the fridge can be connected either here or there. So here's an observation. I just disconnected the battery because rain is coming, and this acts like a voltage reducer. So with the battery disconnected and this was connected, I was basically feeding with around, let's say, 20 volts my 12-volt fridge. So make sure you disconnect first the solar panel, the higher voltage, and then the battery, which is a lower voltage. So I'm not sure if it's still working. That's why it's recommended to connect the battery first. That's a voltage reducer. So let's try to measure the wattage given by the solar panel at no direct sunlight. It gives 15 point something volts, and the amperage is very low, 0.1 amps. So if you multiply those two numbers, we get almost 3 watts. And of course there are no sparks at that low power. Nothing. So at weather like this, you get almost zero power. Instead of 120 watts, I got 2.8 watts. So here you have a 100 watt solar panel. Here we have a fridge that consumes around 50 watts of power. And we have a voltage lowering device. It's a buck converter. And I will power directly the fridge from this buck converter, which reduces the voltage to only 12 volts, and then the solar panel. So the battery is not connected, it's totally covered. So solar panel, voltage lowering device, and fridge. Let's see what will happen. First try. Nothing. It's working. Wow. So there is no battery connected, and the fridge is working directly from the solar panel. No clouds, of course. 220 volt is not connected, that's from the fridge. 12 volt is connected. If I remove this one, the fridge stops. Plug it back again, and the fridge starts. Don't make a short circuit. By the way, this has short circuit protection. And it stopped. So if I cast a shadow on it, it stops. So without a battery, this is working only when there is sunshine. 100 watt mono-crystalline solar panel. It gives maximum 20 volts as an open circuit voltage. Other than that, it's a 12 volt panel that is powered at 12 volts and it consumes around 50 watts, 50. And this is only lowering the voltage. It's lowering from maximum of 20. It will not give, let's say, 20 volts to a 12 volt device. If I disconnect these, the fridge stops. Of course, these are thin wires, they can overheat, but it's working. So let's measure the power consumption of the fridge. Currently we have thin wires. Thin wires are connecting the solar panel to that module, so that will lower the power transfer, but let's just connect them here. And it's set to amps, and this is moved from down here up here, and it's consuming 3.5 amps, 3.3 at 12 volts. Now let's measure the voltage also. Here at the output, 12.5 something volts. You can set that one from this potentiometer, the voltage. So this outputs around 20 volts and this limits it to around 12 volts. So it's running for a few minutes, 10, 15, 20, I don't know. And these thin wires are not hot, slightly warm, I'm not sure. That metal, the heatsink, is just a little bit warm. The efficiency is pretty high, 90 something percent. I don't feel any heat. Oops. Connections are bad. Those. So here I have a 20 meter long cable and the diameter of one wire is only 1 millimeter, so it's not too thin but it's not thick either. And I want to connect this 20 meter wire and let's see how much it will reduce the voltage of that one, because on lower voltages long cables are bad. Let's see how it sounds. I can analyze only the sound now. So it sounds identical, although the power is passed through a 20 meter long cable. The solar panel is highly sensitive, so if I cast a shadow only on one cell, the fridge will stop. It did not stop completely, but 90% less. So I added this 20 meter long cable and it's hot. The 20 meter long is hot. This is shorter and is thicker, 1.5 millimeters and 1 millimeter. And the entire cable is hot. These are not hot, neither this thin one, but this large one is hot. So low voltage, higher amperage, and the long cable heats up. .14 volts. The charge controller starts ticking. It's cutting off the power from the solar panel because the voltage is 14 something. Now only the solar panel is connected. It's making that ticking sound. It's constantly disconnecting the solar panel from the battery because the battery voltage is pretty high. If I connect a load, this fridge, then it will get out from the battery a little bit of power and it should leave the solar panel connected so it can charge it. So the load, the fridge is also connected. Let's power it on. No, it's not cutting it off. The voltage should slightly decrease. So the solar panel is connected to the charge controller's first entry, these two, the plus and the minus. The battery, 12 volt battery, is connected to the second set of connectors, plus of the battery and minus of the battery. And the load is connected to the third set of connectors, also plus on the left and minus on the right side. This is sending power there, and this is taking out power from there and there. Now if I cast a shadow, it should not stop because it's receiving power from the battery also. So let's take a look at the sound. Speed did not drop. Before, when I placed my cap over a cell, it stopped. Now it does not stop. Now it takes power from the battery also. 12.70 and it's rising. Shadow 60 something. Higher voltage with no shadow on the panel. Lower battery voltage with shadow on the panel. I have to adjust the position of the fridge because the sun is going that way. So push the fridge into the shadow. Plus the shadow of the panel is not exactly perpendicular, so I should turn the panel slightly to the right also. Plus that will soon block my sunshine, so I should move it out there. Let's see how much time is needed for this shadow to get here and cover my solar panel. So this shadow is still not here after around an hour, so maybe it needs 1.5 hours or 2. And heat wise, usually this was hot. No, it's not hot, it's warm a little bit. It's not as hot as it was. This is switching on and off, so the voltage of the battery might be pretty high. That's good. This wire is slightly warm, just a tiny amount. The white, they are almost cold, 1.5 millimeter thickness wires. This is hot here, where the PVM word is. Ouch. Somewhere here is hot. On the back it's just slightly warm. Now there is no direct sunshine. Something is there but nothing here. Sun went totally down. But we still have that white LED. So there is something coming from the solar panel. And the battery voltage dropped below 12 volts. 11.96. The charge controller did not turn off the battery yet, so the fridge is still working at 11.9 volts. And let's measure the output of the solar panel. It constantly went down. The voltage of the solar panel is dropping. 96 volts. I mean 0.96, 0.95, 0.94, 93. It's visibly dropping. The sun is going down. 0.05 amps. That's around 0.5 watts of power. Half a watt out of a 100 watt panel. So when sunshine hits the panel you get even 120 watts, but when the sun goes down you get half a watt. So here's an interesting thing. I wanted to measure the morning sunshine's power output, and I connected one lead to the solar panel's thick cable and the other lead is just on the ground. And from the solar panel and the ground we have 4.4 volts. If I lift it off the ground, 0 volts. So solar panel to ground, 4 volts. Just the grass gives me 0.1, bigger grass 0.6, ground 4.4. Stick it into the ground, 4.6. Interesting. 21 volts from that sunshine, which is directly on the panel, and 2.5 amps. So that's around 54 watts of power, around half of the entire power of the panel from the morning sunshine. So the fridge was started. The battery is at only 11.8 volts. Now let's connect the solar panel also. And it's 11.9 and it's increasing. So without it, it drops 84, 83, 82. And with solar panel 92, 93, 94. By the way, pay attention to this button. It was accidentally on hot. I was not cooling my food, I was warming my food. So this has to be green because on heating it's red.